to be a staple. Even if you're not working with text right now, it's just a really fun thing. Well, there's different opinions about that, but I guess it's fun, especially if you like learning languages. It's kind of like acquiring a new grammar and then trying to sort through all the rules. I'll share the slides with you afterwards and some really cool links so you can go exploring on your own. And we're going to try to make this kind of like a 30-ish minute intro, and then I'll hand it over to you to go through some really cool exercises. Okay, let's see if this advances. Okay, so what is regex? It's a shorthand for regular expressions, which is basically just a sequence of characters, in a very broad sense. So it could be numeric characters, it could be characters, it could be weird symbols that define some sort of search pattern. And then once you capture that pattern, using different functions with it will allow you to do various different things with whatever you captured. You can identify, match, extract, locate, a bunch of different things. Regex is something that doesn't just work in R. You can use it across different programming languages, and so it also comes in different quote-unquote flavors. So what I'll be showing you here all works in R, but just know that if you're in Java or Python or whatever, there might be other special things that you can add on that will work just in that environment. This is kind of what it looks like if you're trying to capture something, and you should get an idea of, okay, I'm going to need regex for this if you're trying to search for things like this. So in this one screenshot, the highlighted yellow thing is something you could capture with a regular expression. And just think of it as trying to find the lowest common denominator or some sort of pattern in whatever document you're looking at. And again, I'm using the word document quite broadly, right? So this is like a server log or something like that. So what I'm capturing here, is always preceded by a double quote and a space, and it's always followed by a space and a capital S server. And what I'm capturing in between the string is like numeric with periods, and the last digit varies. It's either a 7 or a 4. So there's a way to write a regular expression that will capture this kind of sequence. Another example would be something like this, where you have a hospital record or a code book from a hospital. You could define a regex that would capture, the categories that are outlined here, like provider category, subtype, code. You could write a regex that captures everything that comes after the description, colon. You could capture everything that comes after values, colon. You could capture the contents of, various different types in a document that has some sort of standardized layout. And then the last example, this one is simple, right? This is a very normal text thing. Maybe you're reading a book or you have a PDF or whatever, and you're really annoyed by double spaces like I am, right? So you could write a regex to capture the double space and then afterward change it to just be one space following a period. So that's the kind of thing that we'll be trying to do today. Some of the preliminaries for those of you that are going to be launching right into working with text after this, you can use regex with either our base functions, or if you're a tidyverse fan, you're going to be using the package stringer most likely. So there's a very long comparison of functions that are equivalents between base and the tidyverse stringer that I linked here. And like I said, I'm going to share the slides with you after, so you're going to get links to all the tutorials afterwards. But some of the common things that I'm also going to go through in this tutorial would be, extracting the contents of something that we define with regex, or detecting whether it's present in your document or in a sentence, and then identifying and replacing it, or just pointing where exactly it is, the location in the text, or splitting based on some sort of pattern. You can do all these functions either with base or with stringer. I'm going to be showing you the stringer side of things just because that's what I'm more used to, but just know that there's always an equivalent in base. Okay, so this is kind of what a regex expression would look like if you're trying to capture something. And this particular image is breaking it down for you. So it's saying, we bracket the boundary of our expression with 2 dashes, and then in between we're stuffing all these weird characters. One of them will match anything that's contained between 2 brackets. One of it will capture something that's between lowercase a through capital Z. Some of it will match a symbol as is, like that at in the middle of this, or, you know, at the end of it, I can specify that I want to capture between 2 and 4, or at least 2 characters. Does anyone have a guess for what this might be capturing? Right, so if I'm reading from the inside out, kind of, there's an at sign that is matched as is. There's a single period that is matched as is, and then there's like stuff in between and stuff after that has between 2 and 4 repetitions. And then there's some other stuff at the beginning that can be alphanumeric. What would that look like? And I think I have stuff in chat. Do I? Email, right? Exactly. It's an email address. Have to move some windows to see your responses. There we go. Yeah, okay. So this would be capturing an email string. And just so you know, right, for a lot of these common things like emails or phone numbers, street addresses, states, there's canned regex out there. You don't have to reinvent the wheel. A lot of this is Googling for a regex pattern that someone already wrote out for you. There. Don't cry just yet, right? It looks really ugly, but once you start getting into it after a couple of weeks, it's really easy to think about the building blocks and then develop something as complex as that string before was. So, like I said before, right, this is kind of like learning a new grammar. So I'm going to be giving you a quick tour of what's out there, and then it's really on you to go and work with it. This is teaching regex. It's kind of like trying to teach you a new language by just explaining the grammar and then expecting that you're going to be fluent right after that one lesson. Like me trying to say, okay, Slovenian works in this way, and this is how you conjugate stuff. Now go and, you know, have a conversation. It's not really how it works, right? So I'm going to give you an overview of the general rules that are really the basics, and then you can build up on those. And as you encounter really specific problems, it's going to get more real, right? Like, and you only get, or you get better at it the more you practice. So the first thing that we can talk about is characters. That's really simple. We all know what, you know, alphabetic characters are. Here's a bunch of symbols in regex and what they capture. And you'll see here immediately that there's some shorthands here. Like I said, this is in a flavor that works in R, and it might be a little bit more intuitive for you to think about. So you can start with this, or that, and then use the more standard notation, which is like an A to Z. But basically what character wrangling allows you to do is things like match characters as they are. You would put them between square brackets, or negate that and match characters that are not within square brackets if you add this caret at the beginning. You can match particular numbers or non-numbers. Here's shorthands and the standard notation. You can specify whether the characters that you want to match are lowercase or uppercase. Again, this is pretty intuitive. Then there's some combinations of that. So you can have alphabetic characters only, or alphanumerics, so digits and characters. And then there's something called word characters, non-word characters. So these are things that would appear, you know, in a standard sentence along with numbers, but maybe not really odd symbols. Or you can have, there's this nifty shorthand that it's really cool in R, where you can just match on punctuation characters. So that's a pretty broad sweep of what we can get with characters. And let's go through an exercise to see what this would look like. If I load the library stringer, which I said is the tidyverse equivalent of working with base R, then, and I pass in this vector called hex. So these are hexadecimal color codes. So, you know, white, this is like an off red, and a hex code for black. And then I ask for, or I pass 2 functions. They're both string extract all, which in stringer, you know, stringer is going to go and extract everything that matches this particular regex pattern in my vector. So I'm saying from my vector hex, extract this regex pattern. And I have 2 square brackets and a 0 to 9. What would be the output in these 3 vector elements? You can put it in chat and we'll see if anyone gets it right. What would come out of the first element, the second element, and the third element if I pass this first function? Okay, we have one guess, that is 0, 0, 0, 0. What would come out of the first one? Yeah, exactly. It would be an NA, right? There are no numeric characters in this first element. What about the second one? 9, 9. Yeah, exactly, right? And here we have a bunch of zeros. And then what if I do this second function that also says, square brackets and capital A to capital Z? And I'm still keeping my numeric call here. What comes out of the first element, the second element, and the third element? Okay, we have some differing opinions. Interesting. Okay, let's see who got it right. I'm gonna pass this. There we go. So from our first function call here, string extract all from my hex vector 0 to 9, the first element, it's gonna come out of as NA, or it's not capturing anything because there are no numeric characters in my first element. In my second element, I have 2 9s. So this is what matches my pattern. That's what's gonna get pulled. And in my last one, I have 1, 2, 3, 4, 5, 6 different zeros. And notice that they're all pulled individually. So it's grabbing the minimum number of digits. In my second function, when I also say, get me all the capital characters, A through Z, and then followed by a numeric character, I get a null vector again on my first element because there's no text here that is followed by a number. From the second one, I get E9 and F9 because this is the only pattern that fits my description, right? So it's a capital character and then a numeric. And then here again, a capital letter and then a numeric, right? CE doesn't fit it because those are 2 letters and I didn't ask for that. And this F also doesn't fit it because it has no number following it. Same with the C. And then on the last one, again, a null because I have no letters here. So it's just the numbers, but I'm asking for a letter that precedes a number. So that pattern is not there. Okay. Another thing to know about regex is how to specify quantity, right? You've already seen this matching on range. So I can say from lowercase a to lowercase z, and that would capture all the letters in the alphabet. Oh, we have a question here. Why do we have preceding a set of characters?
I meant to say, why do we have hash preceding a set of characters? For
Oh,
example,
that's just the text that I passed in there, right? Hexadecimal codes are codes for colors. So if you're specifying a colors for your ggplot or something, this is going to be a color code. And it just so happens that this is the hashtag is in the beginning, and but I could have put unicorn, sunshine, and sunflower in here, or SFD7 hashtag alpha star something, right? This is just random text that I'm putting in. It's just for exercise.
got it. Thank you.
Good. Okay, so we're talking about quantity. So now that we know how to match letters and numbers, we can play around with how many letters or how many numbers we want of a particular type. You've already seen this range command, which, as I said, right, if you do from lowercase a to lowercase z, it'll pull all the characters in the alphabet. If you use a dot, that will match any single character except a new line. So think of it as like a wild card. If you add a question mark to something that you're pulling, it'll say the previous symbol that I specified in my query is optional. And then these two are really handy, a star and a plus. A star will match 0 or more previous symbol repetitions, right? So it can either be present or not. And the plus will match at least 1, so 1 or more. If you want to be more specific with how many characters or numbers of a particular type you want to capture, you would use the curly brackets. And if you just put one number in the curly brackets, that will say, I want exactly X repetitions of the symbol that I just specified. Or you could go with a range and say, match at least at most or between X and Y repetitions of the previous symbol. One thing to know about plus, star, and question mark, so these ones here that make characters optional or have them appear a certain number of times, is that they're, it should be a Y here, greedy by default. So it means they'll match as many characters as possible. If you want to make them lazy, so for example, you know, if I had 3 zeros, it would try to capture the 3 zeros. If you want them to match, if you want them to be lazy or capture as few characters as possible, you would add an additional question mark to them. So that would cause them to only grab the first one. And you know, don't worry about it too much. You'll see when you practice what this all means, but just so you know that there's fine tuning involved here that you can also do. Okay, an exercise on quantity. So I have my hex vector here again with the 3 colors, white, black, and an off red, and these are their hex codes. Again, I'm using the string extract functions and then a string detect. And out of these 3 elements, I'm trying to first extract just this square bracket 0 to 9. And we've done this before, so we know exactly what's going to come out of the 3 elements, right? Does anyone want to take a guess for the first, second, and third? What's going to come out of this first function? Okay, this one's easy. We're just getting started. What's coming out of the first one? Okay, yeah, so first one we have nothing, then we're gonna have 2 9s and then all the zeros, right? So this is just capturing any number between 0 and 9. If I do string extract all and I say, give me the same thing, so I just want numbers, but I also add a plus to it, what's gonna come out? There's a very subtle difference there. I just added a plus. And we just said that these can be either greedy or lazy. Okay, the first one's really easy, right? So nothing's coming out of it. I'll show you on the next screen what the next 2 look like. If I do a string detect, my output is going to be a little bit different now because I'm not asking R to extract things for me. I'm just asking it to detect it, right? So my output is going to be logical. It's going to be a true false. I'm again saying, take my vector and consider these 3 elements and then give me something that I call digit here. So it's a nice shorthand, and then I'm specifying the number of repetitions. So what would come out of this third call? False, false, true. Awesome. Okay, so we already have a correct. Let's see. Yeah, okay, so for my first call, and again, so we're just repeating this. We've seen it twice now. I'm extracting just the digits. There are no digits in my first element. There are 2 digits in my second element, 9 and 9. They're getting pulled separately. And then I have 6 different 6 zeros in my third one. That's what I'm getting out. In my second function call, I'm also adding a plus. Remember, this will capture 1 or more repetitions of something, and it's going to be greedy by default, so it's going to be capturing them all together, right? So you can see here, these 2 9s do not appear in my vector element together, so they're also pulled separately. But you can see the difference in this last element where I have 6 zeros. Because I'm asking it to get 1 or more repetitions, it's getting all of them because it's greedy. So here the zeros are getting pulled together. So this might be important depending on the type of output that you need in whatever function you're calling. And then in my last one, like I warned you, right? So I'm not extracting information, I'm just detecting it. I get logical output of false or true. Again, this is just a different way of saying a range from 0 to 9. So I'm pulling the digits, and I'm saying there have to be at least 3 repetitions. So I don't have 3 repetitions of any digit in my first element. I have 2 digits in my second element, but they don't appear together, so that fails that condition. And in my third element, I have all these zeros, and it's saying, are there at least 3 of any digit? And the answer is yes, right? So I get a true here. Okay. Another caveat, I guess, besides greedy and lazy to introduce before we move forward is that to use any of the meta characters that we've seen so far, so, you know, if you wanted to call something that's used as part of the query, so like a curly bracket, or if you want to call or detect a question mark that also means something in regex, you're going to have to escape it first. And typically you're going to be escaping things with a backslash. This can get really ugly and really complicated, and you'll get back to this meme and you'll laugh a week from now when you're trying to escape something that's inside something else that's inside something else that needs to be captured with this like 25 character string. You'll see it, but we're gonna need it on the next screen, so I'm introducing it now. So basically, if you're trying to use a meta character, so something that's already used in regex as a command, you're gonna have to escape it with a backslash. Okay. So here you can already see these are appearing, right? This screen shows you how to capture blank or empty space in the document that you're working with. We have these nifty little shorthands, blank and space, that will match any blank character or any space character, of which there's, you know, space tab, new line, or a vertical tab. There's also returns and form feeds. If you wanted to capture different types of these spaces, there's S's, H's, V's, and a bunch of other things, right? Some of these will be intuitive shorthands. S just for any space or any non-space if you capitalize it. Then you have horizontal space, non-horizontal space, vertical and non-vertical space, new lines, carriage returns, and tabs. These are really annoying, especially if you can't see them. Sometimes, you know, there's blank space in your strings and you don't see it and your commands are failing for whatever reason. You might want to capture that space and remove it. This is the kind of commands that you're going to be looking at. Okay. I guess I was watching American Psycho and I put this slide together. So Patrick Bateman says, and in the first sentence of American Psycho, I live in the American Gardens building on West 81st Street. And in this string, I want to locate, right? So I'm introducing you to another stringer verb here. I want to take my string and then locate anything that fits --s A to Z. And then in my next function, I want to extract everything that fits blank, A to Z lowercase, and a plus. So these are getting a little bit more complex. I'll give you 30 seconds to think about it. Let me know what the output of the first and the second one would be. Okay, so we have a guess for A, G, and W on the first one. What about the second one? So I have a blank, capital character, lowercase character, and a plus here that you'll remember is this greedy character for quantity. What is this going to capture? Okay, so we have MJA. Any other guesses? Nope. Okay, we have different opinions on this one. I'll show it. Okay, so for the first one, here's what's going to happen. You had good guesses. I think the first one was actually pretty close. One thing that I didn't warn you about is that here we're using another verb, which is locate. So the output is going to actually give me the locations in this particular string and not the contents of the string. And then the next one I'm using extract, which we've already seen, which is going to give you the, you know, it's actually going to pull the content of the string. So in my first verb, the output is going to give me the start and end of what in my particular input vector fits that criterion. So here I'm saying locate something that starts with an empty space and then has a capital character in the range from A to Z. And so the things that are going to fit that are A, G, and W, and someone posted that, which was correct, except that the string locate, and so if my command here was string extract all, that's what I would get back. But because I'm asking to locate that, I'm getting the location starts and ends, right? So if you count all these here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? This starts at 14 and ends at 15. So it's an empty space and an A. And then I have 23 and 24, which is an empty space and a G. And then I have 56 and 57, which is an empty space. Someone is asking why you have 2 backslashes. Is it because we're escaping a special character, right? So remember, I told you, if you want to use a meta character, you're going to have to escape it. So if we go to the screen here, to match any space, you have to do a \s. But because this is already, this is a special string, so we're not trying to match an S or whatever, we need to put another backslash here in front of it to say, escaping the usual regex world, to just call for a match on empty space and not to match for an S. Okay.
So yep. I think that's specific to R also. I think in other languages.
It's not. Yeah, right. So like I said, everything that I'm showing is the R flavor of regex. So a lot of what you learn here and the principles are going to work everywhere, but there's some things that are specific, right? So this blank here, I'm not sure that this works in a lot of environments. The way the backslash and escaping works is R specific. There's probably other things, right? So if you're working in Python or you're working in Java or you're working something else entirely, it would be a good idea to Google regex flavors and figure out what works in your environment. But yeah, thanks for the reminder. Okay. We're gonna explain the second output and then we're gonna move on. So with the second one, when I'm asking it to extract the contents, I'm again getting the actual contents from my vector that I passed. And here I'm asking for a blank space, a capital letter followed by a lowercase letter. And this lowercase letter has to appear once or more, right? Because I have this greedy plus sign here. So what I'm getting is empty space, capital letter, and then as many lowercase characters as there are because of this plus is 1 or more. So I'm getting space American, space gardens, and space west, right? So we've combined a bunch of things here. So we have an empty space, then we're getting a character, and we're also specifying quantity. So we're doing pretty well. We've integrated everything that we've covered so far. Okay, a couple more things. We can also match on position and order. So we've looked at number, we've looked at characters, we've looked at numbers. We can also say, I want this particular thing, whatever it is, to appear at the beginning or end of my string, or at a word boundary. So it's considering the whole thing, not just one particular character. Again, you'll see this pattern repeating, right? If I have a lowercase something, it matches at that particular characteristic versus if I have a capital letter, it's gonna negate that. So this is matching on a word boundary versus matching on a non-word bound, on a word non-boundary. These parentheses, pretty intuitive. It will match something as a group. This is like an or statement in most languages, right? So it means match the symbol that's either before or after this. And I've already mentioned the backslash escape. We have the same string again. I lived in the American Gardens building on West 81st. I'm doing 2 string extract all verbs. So I'm just going to be pulling the actual contents of my vector. And I'm saying, okay, alphanumeric, this wildcard that we discussed a couple slides back, a T, something else that's alphanumeric, and another star. And then I'm doing a similar query, but I'm saying just this first part and then --b. Okay, guesses on what I'm gonna get as an output here for the first one, and then what I'm gonna get for the second one. Go ahead and chat. Oh, this one should be pretty easy. You have no guesses yet. we know what alphanumeric is, right? We remember this from specifying quantity, so it's gonna match 0 or more repetitions of something. A T is just a fixed thing, right? I want something that contains a T in this particular spot, and then this other stuff. And we introduced the dash dash B in the previous slide, so it's something about boundaries. What would it be? It's not going to be the whole string. D, okay, that's a good one. There's a couple more. Hmm, 81st, good. West, yeah, okay, we're getting there. There's going to be a subtle difference between these two. Let's take a look at it. Okay, so here's my output. From my first function call here, I'm getting the, west, 81st, and street, right? If it's easier for you to read it this way, you can look at, okay, what's a fixed thing, right? So everything that I'm going to get back is going to definitely contain a T because that's a fixed character that I want in there, right? So the candidates here are the, west, 81st, street. And indeed, I'm getting all of these because what I'm asking for is 0 or more alphanumeric characters, 0 or more because there's a star here, and then there's a T in there, and then there's more alphanumeric characters for not because this is 0 or more. With the second one, I'm saying just give me this first part, so 0 or more alphanumeric characters, then a lowercase t, and I want this particular T to be at the word boundary. So the falls off because it's at the beginning, not at, right? Not at the end. You can see I have west here. It's at the word boundary. First, the T is at the word boundary. Street, it's at the word boundary. So that's the difference here. And again, we refreshed our memory on this quantity modifier. So that's what I get out of here. Another thing that might be useful is a contextual look around. So sometimes you're trying to capture something that appears in a particular context, but you don't want to spell all of it out, or it's more tedious to be pulling things with the content and then parsing that. You just want to look around literally before you pull something or locate a pattern. So for example, right, there's probably better examples out there, but a bank robber is something different than a river bank, but in both cases, you're trying to locate the same word. Maybe you have some sort of weird document that talks a lot about both bank robbers and river banks, but you only want one or the other, and you want to not pull any content that has to do with the robber and everything that has to do with the river bank. So we might, define a point in our document, in our vector, whatever it is, and say, if the word robber appears in this particular range, then discard that information. But if the word river appears in this particular context, then that's what I'm interested in, and that's what I want to pull. So there's 4 different types of this. There's look aheads. So it's just what you would think it is, right? You either look ahead from a particular point, and then there's look behinds, which are the opposite. So you look behind before you execute whatever you want to execute. And then the look ahead and the look behinds can be positive or negative. So, and that's hopefully intuitive as well. So it's going to be a positive look ahead if you will be looking for a particular query following your current position, and negative if you do not want that query to be there. The same thing with look behinds. The symbols that you would use to capture something like that are a little bit more complicated. So there's multiple characters involved, but it'll become second nature if you have to use this a lot. Question mark equals is a positive look ahead. Then we have question mark exclamation point. Exclamation point in a lot of languages is going to be the symbol for not. So, it negates something. And then we have this equal or less sign for a positive look behind, and a behind, so like less than, I guess, and an exclamation point as a negation for a negative look behind. Okay, we're gonna try this one out as well. Okay, so now I have something different. Let's say I'm working with a form type data. So I'm defining this vector here called patient. And in this vector, I'm saying it's a character vector. I'm saying name, colon, space Jane, age, colon, space 25, and she's in great condition. Then I'm doing two different functions, or two of the same, that one that we've encountered the entire time. So I'm trying to extract something. So from this vector patient, I want to extract something, and I'm doing, you'll remember this, it's a look behind, right? Name. And again, this one, but also I'm adding dash dash W plus. So what would the output from these two commands be? The first one and the second one, and I'll look at chat. If you need a refresher, right, so here we have, this is what I just showed you in the last screen. So I'm telling you it's a look behind, and this one is a dash dash W, which is for word characters. And this one is a quantity modifier where we said one or more. Okay, we're getting 2 of the Jane. That's a good one. I just don't know which function it pertains to. What would be the output of the first one though? Just J. Any other guesses for the first one? Okay, I tried tricking you for the first one. So here's what the output would be. What the first function is doing is saying, look into the vector patient, do a look behind, but there's nothing that matches, right? I didn't ask for any extraction. I didn't ask for anything. All I said was look behind, period. I didn't actually ask for any content. So what I'm getting back is empty. In the second one, I said, okay, look behind, and then give me everything that is a word character and give me one or more of those. So for the first one, it's looking behind from this particular point. It's saying, okay, here it is. It's capital N, A, M, E, colon, and a space. But then it didn't do anything with that information because I didn't ask it to, right? So there's nothing here. This is my look behind, but there's nothing following the look behind. In the second example, I'm doing the look behind, and then I'm saying, okay, if it fits this condition, then give me everything that is a word character and give me as many of them as there are. And Jane fits that condition, right? So here's my look behind, and this is everything that fits this condition, and then there's a line return, or a return here, which is not a word character. So anything after Jane will fail the condition. So that's what I'm getting out. So that's how look behinds and look aheads, positive or negative, work. First, you define your look ahead or look behind, and then you say, here's what I actually want to pull out of it. Because if you don't say what you want, it'll just look, but not do anything with that information. We have a question. How is dash dash W plus different from dash dash W in this case? So if you just did dash dash W, it would just pull one character, versus the plus is saying, give me one or more of those characters. And if you put the alphanumeric in the place of dash dash W plus, will it give you the same thing? Yes, right? Assuming that we're thinking about word characters. And again, so this is an R regex flavor, so this might not hold everywhere else, but the way alphanumerics are defined versus word characters technically should give you the same thing, provided that you also have this quantity modifier here. So we would get all of them, not just the first letter. And then I have another question. If there was name colon Jane 4 times in the patient string, would it return Jane 4 times? I'm assuming you're talking about this one. So it would just keep going until I hit something that is not defined as a word character. Yeah. So if I had Jane, 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 until I broke and there was like a carriage return like it is here, I would get Jane, 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 Jane out. Okay. Hopefully that was clear enough. So Here's one more. If there were multiple different patients in the same string. Yeah, so if I kept, you mean like in a column layout. So if I had more content here that was again followed by name, age, condition, name, age, condition, then yes. Yeah, it would return everything that follows anything that looks like this. Yeah, okay. Go. If this was really confusing or you're feeling like you need to go work with text and it's too overwhelming, there's a bunch of nice starter packages that I want to mention in R that you could play with. So there's this package called Regex that has some shorthand or more intuitive names for some, like a canned regex that might also help you if you're collaborating with someone who's not familiar with regex or doesn't necessarily need to learn at this point. It will turn long queries like this into something that's like a label. So this is something to look into if this looks too scary and you want to start from like an easy place. So you'll have wildcards and lookarounds that are predefined for you. So if you just do, you install the package and you put question mark Rex, it'll give you a bunch of nice little vignettes that you can read and play around with. It might be more intuitive. Another one is QDAP regex, which is like an instant regex or canned regex that's already pre-composed for you. So if you don't want to Google for, an email regex or a phone number regex, you might go to a library like this one and it'll already have those things in there for you. And you can just use easy commands from that. Okay, don't want to spend too much time with that, but just so you know, there's stuff to play around with. And now I want you guys to try it out. Like I said, this is like explaining grammar to someone and expecting that they'll be fluent in it. It's not really how it works unless you try it out first. I have a couple of cool websites, and this one sometimes does or does not work. Unfortunately, it doesn't work right now, but it's a really, really cool regex game. So I'll share the slides with you. And if you have time afterwards, I highly recommend you go to this site. But I'll copy paste these two links into chat right now. Let's see, to everyone. So you can pick one of these. They're both regex games. You have both of the links in chat right now. I'm gonna put you guys into breakout rooms of, I guess, around 3 participants. And I'm gonna start this timer for 30 minutes here and see if you can, or how far you can get in either one of these games, your choice, depending on which one you like more. You could probably do both. And then we'll reconvene in 30 minutes to touch base on how that went. If you Okay, seems like we're at about the same number of participants that we had before. So I'm sorry that this first link didn't work. We did this one last time. It's like a gamified regex challenge where you go up levels when you complete challenges, and each one is like harder than the other one. So if you are going to be working with text, I highly recommend that you come back at some point and try this one. It was really fun. But even the other two, hopefully that gave you a sense of what constructing regex queries looks like, what kinds of things you can capture with it, and gave you some more like hands-on that I can't just explain by walking you through these really toy examples, because as you know, and you probably learned by now, we're on like week 3, right? Data is really messy, and the toy little things that we show you where everything is nice and neat and clean, that's not really how data that we work with usually is. So you have to get your hands kind of dirty. So I'll share these slides with you in the training, I guess, folder or Teams channel that you all have access to. And at the end, I also gave you a couple more practice things that you might want to look at. So there's a bunch of lessons out there that I found really helpful. There's the free code camp, which is like a data camp equivalent lesson kind of series, I guess, available if you're going to be needing more than this. If you want canned regex, so I mentioned this before, if there's particular queries that you think, someone already developed this. So when you're looking for things like emails or phone numbers, addresses, states, first names, last names, social security numbers, what have you, there's canned regex for that. So you can go to any of these links and look up what those typically look like, and then you can build off of them, or you can just use them as they are. So here's 3 useful links for that. And if you want to play some more Regex games along the lines of what you just did, just to practice, maybe if you don't have your text data yet, or you're waiting for documents from your sponsor or whatever, here's a crossword in another game. And then for slides, I don't think this is on the training slot this year, but if you like the slides, this is all done in R, and you can play with Zaringen to make something of your own that looks like this for when you're teaching a Regex seminar. But anyway, hopefully this was a good warm-up for, I think you have a text mining training slot scheduled for after this. So this is like a small part of wrangling text and text data and searching for things in documents. Think of it as a, yeah, I guess like a warm-up practice run for what Devika's going to be discussing with you in, I guess, an hour or so. If you have any follow-up questions or anything, you can find my email, or you can tag me on Teams and let me know. But otherwise, I'll let you go with an extra 10 minutes.